right, I hope everyone is having a great day so far. So today I would like to kind of talk about the basics of how to write a smart contract, an assembly script, or a smart contract for the Koinos blockchain. So to do that, there's actually a few tools that you can use to kind of bootstrap a smart contract. First, you will need to have Node.js installed on your computer. That's fairly easy to install. Just head over to the Node.js website and then just download the binary for your computer. So that's one thing that you need to install. You can look for my personal GitHub user. This one. I can write down all the links later on if you need to. But basically, we need the repository to go to the repository called koinos-sdk-as-cli. And then if you scroll down, you'll see the command you need to use to install the CLI. So what this will do, I open VS Code here, I open a new terminal. What this will do is just install the CLI. Yeah, so now that the CLI is installed, we can start creating a contract. So I'm just going to open a folder. Here, and then I'll create a new folder, contracts. And inside this folder, sorry. So if I start the CLI again, you can see there's different commands available, and the one we're going to use right now is the one called create. So I click create, and then the name of the contract I want to generate. So in this case, we'll just call it hello world. So now I have a hello world folder with all the files needed to bootstrap the contract. So if I copy this command that the CLI gives you, you paste it, it will install all the dependencies that the contracts require in order to get compiled, and also it will make sure that it's able to run the unit test for the contract, so that you'll be able to know if your dev environment is all set. So basically, the proto file is just a way for you to describe first all the functions that are going to be available for your users. So each function comes with arguments and results, kind of like in this example here. So the hello arguments is basically what the function hello will take as arguments. So in this case, we know that we need to provide a name argument, which is just a string. So when we call the hello function of the smart contract, we'll have to provide a name. And then the hello result here is just the result that we'll get after calling the contract. So a few things to know when you describe a contract function. You have two identifiers that you use in the comments that will be used to create the API file. So the API file is just a file that kind of the interface between your contract and your users. When you create your function, your smart contract function, you can describe with the description decorator here. You can describe what the function does. So that's what the say0 here. That's what the end user will see when they load the API file for a contract, either in the Koinos CLI or if you use it with the koilib, the JavaScript library will allow you to interact with the Koinos blockchain. Either you're just asking for data, you're just basically reading what's on the blockchain. The read-only functions are completely free. They don't require you to submit a transaction to the blockchain. It's just like a HTTP GET to get data from the blockchain. So that's the case of this function here. It's just a read-only function. It just takes an argument. It will return a value here, and this all happening for free. You don't even need to have a Koinos account or nothing. And then you have the functions that are read-only false, and those functions actually require you to sign a transaction and submit the transaction to the blockchain. So why do you have to have a read-only false? Basically, when you need to store data, most likely it's because the function you're calling is to store data on the blockchain or change the state of the blockchain. So in order to change the state of the blockchain, you'll have to pay for the resources you're using just by using mana. So, well, when I say pay, you're not paying directly. It's free, but it'll use your mana when you call a function that's read-only false, just because you're changing something on the blockchain state. So those are the only two options you have. Whatever you put here, those two descriptions will show in the API file. And that's basically what the Koinos CLI will use to know if it needs to generate the transaction or if it just can read from the RPC API. So if I look at the API folder, I should have two files. So one called helloworld.proto.json. So this is the API file that's compatible with the Koilib library. It's also basically compatible with the protobuf.js library that you can use to just do JavaScript scripts to get data from the blockchain or even generate transactions. And then you have the helloworld.api. This is the API file that's compatible with the Koinos CLI. So that's the one you will be actually loading to the blockchain when you have a project. And that's also the one you'll be retrieving, the Koinos CLI will be retrieving from the blockchain when you need to interact with the contract. So that's the API folder and the API files. The proto file is really what you need to focus on first to kind of describe everything that your contract is going to do. It's also where you are going to describe objects that you would want to store on the blockchain and that you'll be storing in the database. I kind of explained this later, I think, but yeah, just keep this in mind. So the proto file basically is also used to generate all the boilerplate for your contract. So you don't have to think too much about it. So the way it works, if I go back to the hello world, so basically you can see here that the SDK generated, well, actually not the SDK, sorry, the CLI. The CLI, when you compile a contract, it will read the proto file and then generate two files, the hello world.boilerplate.ts file and the index.ts file. So the index.ts file, you should never have to go in this one. This is just the entry point basically of your contract. That's what the blockchain will call when they load your contract and call a function. But basically what it does, it just gets the entry point from that the user entered in the transaction, and then gets all the arguments provided. And then by using the entry point, it will just choose which function of your contract to trigger. So it's automated. You don't really need to go into this file. But if you wanted to change this file, you could definitely do it. It's kind of an opinionated way of doing this, but you could definitely do it another way. But this is the most simple way, I would say, to generate the entry points for the contract. But yeah, this file, just remember you should never have to go in this one. The one that's more important is the helloworld.boilerplate.ts file. So this one here basically is just a class that represents your contract. So the name of the class is the name of your contract. It's actually the name of the package you put in your proto file. So this here I created a class that represents your contract, and then for each function that you describe, so a function in your smart contracts, it's actually two messages. It's a function underscore arguments and the function underscore result. So when the CLI compiles your profile, it will see that it needs to generate a function called hello in your contract. So if I go over to the boilerplate file, I have here my hello function, and then it knows that the arguments are called hello arguments, and there's a name, and then the result is as a value property. So it will generate kind of the boilerplate of all the arguments and results that you can use in your function. So you can see here the hello arguments and then the name properly here. And same for the result. You have the hello result here that was generated, and here you have the value that you can populate to return. So the way you do this, basically, everything in your contract is generated from this proto file. So here in this file, if I want to create a calculator, I just copied those arguments and result here. I moved it here. I changed the description to a new description, and then I need to check if my new function is going to be read-only or not. So calculator doesn't need to store data on the blockchain. So in our case, not really, unless you want to, I don't know, store the result for the calculation, but in most cases you don't need to. So I'll keep this read-only to false. And then here I need to describe, to type the name of the function that will be generated. So in our case, it'll just be called add arguments, and then I'll need to take two arguments, I guess. So you can check all the different types available for protobuf protocol, but I know that there's a 64 available, and let's call it A, and then the second argument will be B, and then you need to change the number. And then the result will be a unit 64 as well. And I can keep the name to value. I just need to change it to. So yeah, that's how you add a new function. So once you're done with your profile, what you just need to do is use the CLI to recompile your contract so that it can generate all the boilerplate files again. So if I go, I believe it's below. Then I need to choose the build mode. So that's really hard debug. I'll use debug because it's just a little faster right now. So actually, the difference between the debug and the release, it's the size of the file is dramatically lower and smaller when you debug in release mode, but it also takes longer for the compiler to generate the wasm file. So I'll use debug here, and then the proto file names I need to provide here. It's basically the name, just the name of the contract. The proto file I have here in the proto folder. So the helloworld.proto. Okay. So this is basically going to read the proto file we just updated again. You have here a compilation error. It's just because we haven't updated the contract yet to take into account this new function. But if I go over back to the boilerplate file, I can see that a new add function was added here, and you can see the two arguments we added, the A and B, and then the result here. So the boilerplate is not what is compiled at the end. It's just for you to see, to get the code that that's auto-generated by the CI. So here now I can just copy-paste this add function and put it in my actual contract, which is the helloworld.ts file. And now I can paste the add function. But yes, so the helloworld.ts file, I think I haven't expand this file bit, but that's actually the contract file that will be compiled to wasm file, and it's actually the file that has all the logic for the contract. So if I look at the hello world function, basically what it does is retrieving the arguments from the transaction, or not the transaction, but the arguments that the user entered, and then it creates a result that will be returned to the user, and it basically just does generate a string with the name provided by the user. And then the system.log, I'll go over what system is after, but in this case here we're just logging the result. So it will generate, it will log the hello command name to the logs, the block, the transaction logs. But I'll explain this later. But in our case, for the add function here, I'll just uncomment stuff here. So let's say we're getting the A and B arguments from the user. Here we'll type the logic and we'll return the result. So we already know that the result is going to be. Well, actually, I'll do the calculation real quick, but let's call it the result. And the result is just going to be A plus B, but very simple here. And then I know I need to become C. So that's a very actually bad way to do that, because it's a blade script. Integers, they can overflow and underflow. So this means that A plus B might not be equal to what you think it would be equal to. So there's actually the helper that comes with the SDK. So here, if I import, I wonder if I can. Yeah, I can. So the IntelliSense for TypeScript is actually pretty good. And since assembly script is just TypeScript, let's say it's TypeScript, you can leverage all the TypeScript tools that actually come with the VS Code or the ID, whatever ID you use. So the IntelliSense is pretty good. So in this case, it's able to know that I have a SafeMap library available on the SDK. And now I'm able to just use this helper to calculate safely this addition here. So I can just do, I believe, do the add one. So also all the functions in the SDK, they all come with some documentation that's integrated in the code. So you can see here the parameters for the function are explained, and also usually have example here at the bottom. So here it returns, it will revert the transaction if there's an overflow. So I guess we can just use the add directly. So here I'll do A and B. So now I know that the C here is always going to be the expected value. And so now I can return it safely to the user. So now I did my add function. I can compile the contract again, and this time it should compile just fine. All right, that worked. So so now that you're done writing your function, what you need to do is actually unit test it. So let's go over to the test folder now and see what unit tests look like. for assembly script smart contracts. So it already comes with a sample test that's actually testing the hello function. So it's very much like Jest for those who are familiar with the JavaScript unit test software with Jest. So you always describe, it's always working as you have a describe that's basically describing the set of test row that you want to test. And then you have the it, or you have different ones. You have test or it functions that describe one unit test, and then you have the expect to describe the test itself. So in this case, what we're testing is make sure that when I pass the word argument to the hello function of my contract, I expect this result to be hello world. So when I run this test, I know that is returning correct result. So now let's say I want to make sure that my add function actually works. So I would just do the it, and then describe the unit test. So first I need to make sure that I instantiate my contract. So my contract is still called the yeah. So what I did basically here I instantiate the contract. So most likely you'll have to do it every time, and then you need to create the arguments for the functions you want to test. So in our case here, actually I'll just review it. So to access the arguments objects in assembly script, you can see here actually the CLI imported directly the proto file, the compiled proto file. So if I now use this import, I should have access to my other arguments. So the other arguments is what is going to be sent to the add function we just created. So I add two arguments. So the goal here is to add 3 to 8. So I then call here the function, the contract, which is the add function. I pass the arguments I just created, and then here I get a result, which is the add result message described here. So I call the function, I get the result, and now I expect this result, the value that's inside the result, to be equal not to 7. Yeah, so I expect this result to be 11. So that's it's only one case tested, but that's the basic of how to write unit test for a function that's read-only. So now I should be able to actually call the CLI again. You guys can see what I mean, right? Okay, cool. Yeah, so well, actually, so to run the unit test again, I don't have to compile the whole contract, etc. I just the CLI provides a function that you can use to just call the unit test. Okay, let's run dash test. And this is just going to run the test. You just write it. we just wrote. So in our case, you'll run those two tests here. So if everything goes as it should, the test I just wrote should be success here. So this worked. So I guess you didn't hear my explanation regarding coverage either. The one thing that comes with the unit test library, and that's very interesting, is the coverage. So you kind of know, you're able to know if how much of your code is covered, which I think is kind of important to know when you write a smart contract. You don't want to miss any function or any edge case. So it's good to have 100% here showing. That means basically you tested all the path in your code. If I had an if here, something, then there it wouldn't show if I didn't enter this actually. Let's see. So now if I run my test again. Okay, can you hear me now? Okay. So I was just saying the coverage is important to see 100% here. So I just added this if here to show you that if you miss one case, if there's something you're not a path in your code that you're not testing, the coverage here will not be 100%. And it will kind of indicate what you need to. Right. Yeah. So yeah, I just added this if here to show you that my coverage is not 100% now, so I just need to create more tests to make sure I cover this if here. So yeah, now I'm done with the unit test. I'm just going back to explaining a few files in this. Yeah, so let's actually deploy this contract to the blockchain and actually test it with the koinos-sdk-as-cli. So in order to do this, you have to download first the koinos-sdk-as-cli. So if I go back to GitHub, the koinos repo. So here I have the koinos-sdk-as-cli repo. So head over to the release here, and then just download the binary for your operating system. So I already downloaded it, but just choose the correct binary, and then you'll just end up with the zip file. You just extract the file, and you'll get the executable. So now, which folder was this? So it's one. Let's go here. I'll open it. So let's check that the CI is actually working. Now it's working. So so to deploy my wasm file onto the blockchain now, the first thing I need to do is actually create a wallet. If you not already have one. So let me check. I think it's create. Yeah. Create, and then hit enter. You'll see what this create command is waiting. So the arguments are finding and a password. So I'll just call it my wallet, and then enter. So I have a new wallet available now with this address. So what I'm going to do actually now is connect to. I need to connect to an RPC server, an RPC node, in order to be able to interact with blockchain. So now I need to connect RPC. Can you guys hear me? Okay. Connect to an RPC. I think it's just a URL. I know the one. So the Koinos team has HTTPS. Oh yeah. Okay. I think it's now I'm connected to the RPC, so I can type balance and it should have 0. So since we're on testnet now, you can head over to the Koinos Discord and then head over to the faucet channel. And then here I'll just type emission mark faucet, and then I'll just paste this new address I just created. This will send me, I think, 100 T coin, which I can use. All right. So now if I type balance, I should have my 100 T coin. So those 100 T coin would come with 100 mana. I won't go over what's mana and how it's generated, so but now I have 100 T coin available for me to upload contract to the blockchain. So when you upload the contract onto the blockchain, it will be uploaded onto the address, the wallet that you're using to upload the WASM file. So in our case here, I'll be suppose here. So to actually upload the WASM file, I think it's, if you look at the hub here, it wants the file name. So this is the WASM file and then the ABI file. So I'll type upload, and then I need to go back. Intelligence is actually pretty good. The auto completion, sorry. Hello world, so that's what my contract is, and now I need to go in the build folder, and then to the release folder. Now here I should have my contract that wasn't. And now the second argument is the API field. So let's go here. API folder, and then the API that you can upload to the blockchain and is compatible with this koinos-CLI is the one that's called. So here, and now if I hit enter, it will generate a transaction and submit it to the blockchain. So you can see here, so you need mana in order to be able to upload a contract. So you can see here I used this much mana. So you need to wait a little bit for the block to be minted. To be minted. So if I won't be able to check right here. Actually, you can go to right, yeah. So here you get the transaction ID that was used to upload your contract. So I can just copy paste this, this address, and then I believe it's v3. And then I think it's /tx. I can just paste here my transaction. Right. So if it's available, I mean, if it's been included in the block and it's been minted, you should see the details here. So actually, if I click here on operation, I can see how we uploaded the contract. This is the bytecode of the WASM file. And then here you have the API file that was uploaded as well. So now what I can do is I can, so yeah. Well, I can show you that. So just try to remember this. Actually, I'll just copy it. So this is the one that's on the blockchain, and the one that was generated and uploaded is this one. So if you look at those two, I think I can. Wait, I'm not showing. This. Oh, right. Yeah. But yeah, it is. It is. If you look at this part here, it's exactly the same. So yeah. So now that that's on the blockchain, I can actually load this contract into the CI, so I can start interacting with it. I don't remember what the code actually. Oh, it's register. We just so you have to register the contract first. So to register, I think you just have to provide a name and an address. So the ABI file is optional here because when you upload the contract, you don't actually have to provide an ABI file. Since we provided it here, the end user, they don't have to worry about it. So here I'll just register my contract. So I'll just give it a name, but it doesn't have to be the name of my contract. But I'll just call it my contract just to show that it doesn't have to be a contract. But for me, it's just this will be used by the auto-completion to show you all the functions available for this contract. So register my contract, and then I need to paste the actual address of the contract. Yeah. When I do this, the CLI is going to check if there's an ABI file available. So in this case, there's one available, so it will load the file, and then now if I type my contract, I should have the functions available. So if I add two numbers, if I hit enter, so what actually first, whatever you what I described earlier in the profile, whatever you put here in the description, that's what the user will see in this UI. And then, so now if I hit, here, if I hit enter, I can see the different arguments that this function requires. Can Okay, can you hear me now? All right. Yeah. So yeah. What was it? Oh yeah. Actually, I think I changed something because it shouldn't have created a transaction. I may have changed the profile, then I didn't save. I saved it incorrectly. Because here in our API, we don't. Yeah, it should be true. Yeah, so well, that's a good example actually to show you that you can actually update a contract. So you can see I had a mistake here. Should have been read-only because those don't write the blockchain. So I'm going back to compiling this. We'll compile this. So let's wait for this to compile, and then once it's compiled, I will re-upload it again. So I should have my command here. So one thing, since now my ABI changed, I need to close. Actually, it's so that I can load the new API. So like we did earlier, let's double check that the transaction was actually set. So I go back to the Explorer. See what transaction is here. So now if I look at the operations, I should have the new API. So this is what changed. So now, if I registered, I need to connect to the RPC node. My mana balance went down because I just uploaded the contract. Now I register my contract again. Which is this one. Oops. So now if I do my contract add numbers, I should get the result directly in the CRM. So yeah, that's kind of the whole process to upload the wasn't file network. Sorry. yeah, that's kind of important. If I do the L1, here I think I just type a string, and it should be there. That was just a simple contract that doesn't even store anything on the blockchain. So what you have to pay for is just the mainnet.